Hey guys, welcome to this first video in the TurbulenceFD series. In this video, we're going to be talking about the voxel. So what exactly is a voxel and how does it work with TurbulenceFD? Well, a voxel is just two words combined together. You have volume and you also have pixel. So if we take those two words and we combine them together, we get voxel. So basically, a voxel is just nothing more than a volumetric pixel. So what is a pixel and how do you make it volumetric? Well, we know that a pixel is just a flat 2D square. So if we want to give something flat, like a pixel, volume, how do we do that? Well, we just give it thickness. So it actually becomes a cube. So basically, a voxel is nothing more than just a cube. So how do we make a voxel grid? Because that's how TurbulenceFD works. It has a container object, and inside of that container object is a voxel grid. So basically, all you have to do is just take your voxel cube, which that's basically what a voxel is, and you start turning it into a grid. So you have, for example, here in this little illustration, you have one layering of voxels, and then on top of that, you have your other layering. So basically what we have here is a voxel grid. Or if you want to think about it this way, what we've done is basically take a cube, put it in a cloner object, and then set the cloner object to grid mode. That's basically what a voxel grid is just a bunch of cubes in a grid array. So now let's jump over into Cinema 4D and take a look at the container object. So to get to the plugin, you can go to Plugins, TurbulenceFD, and if you click the little dotted lines up here at the top, that will undock that to where you can actually make a separate window and kind of move it around or tuck it out of the way somewhere if you want to. However, mine is already docked up here at the top in a little palette. So what we want to do is click on the container object. It's going to create a container object for us. And the way this works is that anything inside of this container object is going to be affected by the smoke or fire. So if you have any object that's on the outside of this container, it's not going to be affected at all by the smoke or the fire. So whatever you want to be emitting or affected, say by a collision with the smoke and fire, it needs to be inside of this container object. So by default, it's a little small. So if we look over here at the properties for it, we want to make sure we click on the container tab for the container object. And we have voxel size, grid size, and grid offset. Now right now this grid offset, that's not really something that I have ever actually messed with. I don't really know anybody else that's actually gone into it to offset it. But for right now, we're just going to mainly concentrate on the voxel size and the grid size. So right now we can't really see the size of the voxels or these cubes that are appearing on the inside of this container. We don't know really how small they are or how big they are. We really don't know. So we need to quickly go over into the Viewport Preview tab, and we need to turn on Show Grid. And that's going to show a little grid over here on the end. And we just need to zoom in a little closer to see it. And you can see now we've got all of these little squares in here that are kind of arrayed in a checkerboard type pattern. So if we go back to the Container tab, this is where we can adjust the voxel size to make these little squares here. We can actually make them smaller or larger. Now again, remember, you're going to have to imagine that this whole container object here is full of cubes. And those cubes, otherwise known as voxels, are the size of this grid over here. So every single one of these little squares that we see here represents a voxel. So just imagine if you were to take all of these and kind of give them a depth effect and spread them out to where they were going across the entire container, well, that's how many voxels would be inside, or how many cubes would be inside of the container. So we can make them smaller or larger. Now, whenever you're running a simulation, if you take the size of these voxels down, so we're just going to take this number down, you can see they're getting smaller and smaller. What that means is that it's going to take longer to simulate it, but the resolution is going to be higher. Now also, if you notice, over here we have a max memory usage. So it's giving you the layout here of how many voxels you've got. You've got 217 by 217 by 217. Now for the CPU, to run this simulation, if we were going to use the CPU, it's going to take approximately 675 megabytes. If we're going to use a GPU, then the GPU simulation is going to take roughly right about 380 megabytes to do it. So anybody with a GPU with a gig of RAM on it should have no problem simulating this. But at the same time, this container is a little small. So let's see what happens if we take it up. So what I'm going to do is I'm just going to take the grid size value here, and I'm just going to increase this number a little bit. All right, so something about there. All right, so you can see there's quite a bit of voxels in this container. And you'll also notice that the memory usage went up considerably. So here for the CPU, we have right at about, it's pushing 9 gigabytes. So that's how much is going to be needed for this. And also here on the GPU, we have 5 gigabytes. Now, keep in mind, if your NVIDIA GPU has less than what is required here by this number, then you're not going to be able to use the GPU. It's automatically going to switch over to the CPU. So for a quick example, my GPU only has 1 gig of RAM on it. So there's no way I'm going to be able to simulate this using my GPU because the GPU is requiring at least 5 gigs of RAM on it. So this is going to require a really beefy GPU with a lot of RAM on it. However, you'll remember that we took the voxel size down. So we can actually bring it back up. So I'm just going to take it to the default value of 1. Okay, so now you can see that just by taking that value back up to 1, we've now decreased the maximum memory usage. And you can see now the GPU has gone down from where it was at, from 5 gigabytes. Now it has come down to about 548. So this is kind of one of them things where you're going to have to adjust it according to what your scene requires. Now, when dealing with these simulations, especially with those of you guys that actually want to turn the voxel size down and you actually got a lot of voxels in your container object, this is going to require a lot of hard drive space. So if we look over here, we have the cache option here. So what I'm going to do is I'm going to click on Browse, and this is going to open up a little window here, and basically it's just asking you where do you want to set the cache at. So I have a storage drive, so I'm just going to use my storage drive here. You can see I already have a folder here called TFD cache. So you can see that I've already got one cache file already in there, and it's running at about 7.8 gigabytes. So just be sure that whatever drive you have, that it's got enough room on it in order to accumulate all of these cache files. Now, when dealing with these cache files, there's several different options here that you can do. You can create a new one, you can rename it, you can delete it, you can compress the cache, or you can lock it. Now what this means is that, let's say for example, we create some type of fiery explosion and we're really happy with the results, but we want to maybe change something, but we don't want to mess with the particular cache that looks good. So what we could do is we could just click on the cache that looks good, and we can just rename it. And I'll just rename this one for this example to something like good. So this is the good simulation that we don't want to touch. So now we have this one, and let's just go ahead and lock it. So now we have this cache locked. Well, now we can just click on new. That will create a new one. We can just rename it to whatever. And notice that this one here is not locked. So what that means is that this cache here is completely locked, and regardless of what happens, it's not going to be messed with or adjusted. We can always come back to it later and unlock it if we have to. So these are just some of the options here for the cache file. It's pretty self-explanatory. It's pretty easy to figure out. Basically, you're just caching files to your hard drive, and then you have the option to lock them. That way nothing will happen to them. Or if you want to, you can actually go into the folder where they're at and just make a backup of them if you choose to do that. All right, so hopefully that has explained exactly what a voxel is and how voxels are used here inside of TurbulenceFD. So this is going to conclude this part, and in the next part we're going to continue on with getting into more of the container object and all of the different options for it. So as always, thank you guys for watching, and I will see you when the smoke clears.